Howdy. In this MMET 370 lab number 7, I'm going to talk about the Otto cycle that we use in four-stroke gasoline engine. Otto cycle is a thermodynamic cycle that describes the working of a four-stroke gasoline engine, which consists of four different processes. As we can see on the screen, we have two different diagrams. On the left, we have pressure versus volume diagram, that's PV diagram, and on the right, we have temperature versus entropy diagram, that is TS diagram. So let's see what are the four different processes. From 1 to 2, we have a isentropic compression. From 2 to 3, we have a isometric heat addition, that means a constant volume heat addition. From 3 to 4, again we have a isometric expansion, during which our entropy remains constant. And again, to close the cycle, we have 4 to 1, which is again isometric heat rejection, that is a constant volume heat rejection. So in four-stroke gasoline engine, we have four different strokes to complete this cycle one time. It will start from an intake stroke, during which your intake valve will open up and air and fuel mixture can come in. The second is compression stroke, during which both the valves are closed and your compression stroke will take place as piston comes up and it will compresses the mixture. And the third one is a power stroke, during which the spark plug will ignite the mixture and the power stroke will take place and piston will come down. And the last one is a exhaust stroke, during which your exhaust valve will open up and it will allow that exhaust gases to go out, and then it will repeat the whole cycle in a quicker way. So that's a whole four different strokes to complete one cycle. Also on the slide you can see a comparison between the actual four stroke versus the ideal four stroke. So the ideal four stroke just consider the air has a mixture or air has a gas inside the cylinder, but in actual we have air and fuel mixture which makes the combustion happen. During the experiment, student will monitor the real-time parameters at two different conditions. Number one, first we'll run the gasoline engine at high RPM, it's around 3000 RPM, and student will monitor and record all the engine parameters. Then in second step, that's number 2, we'll reduce the RPM and will run at around 2500 RPM, and then they will repeat the same step of recording all the parameters. So we'll start with measuring the engine parameters like engine speed, engine torque, and engine power. After that, students should also record ambient air temperature, exhaust gas temperature, and airbox differential pressure. Lastly, students should also record fuel flow rate. Now once students have recorded all the engine parameters, they will use that value to find this derived parameter for the data analysis for report summation. In this, they will find heat of combustion, then inlet air enthalpy, air mass flow rate, fuel mass flow rate, that will help to derive air to fuel ratio and also specific fuel consumption. Student will also calculate thermal efficiency, volumetric efficiency, and brake mean effective pressure. Now, all the equations used for this calculation are available in the lecture notes and also in the lab manual, so please refer to that for further details. And in the next part of this video, I'm going to discuss and talk about the actual setup we have for this experiment. Okay, howdy, I'm Digvijay, and as you can see over here, I have the experimental setup what we use for the gasoline engine. Over here we have a four-stroke single cylinder gasoline engine, and it's been instrumented over here what we call an instrumentation panel, and I will go through each what are different sensors inputs over here. Okay, so firstly you should make sure you must add some fuel over here, which is the main fuel tank. Okay, and as you can see, we have kept this instrumentation panel at a certain height from this gasoline engine because this is a gravity fed a fuel tank, there is no fuel pump. That's why we have to make sure it is at certain height so fuel can flow through easily. Alright, after that we'll instrument all the sensors properly over here. As you can see, these are my two inputs over here. So one is my torque input, the black color, and the gray color is my speed input, which will help me measure the speed and torque on the screen. In the same fashion, I am also taking input for different thermocouples over here. This is my ambient temperature input, and this is my exhaust gas temperature input, and this will be monitored over here. Also, as you can see, this transparent tube over here, it's been connected over here to measure my airbox differential pressure. So you will see all these three parameters on the screen. Okay, moving on, I think that's all for the instrumentation things. Also, please make sure you should power this device. So we have this power cable over here, and there is a power cable at the back side, so make sure you connect that power to the main supply. So just for this video, as we are indoor, we are not going to run the experiment, and that's why I'm just making a point how to connect and how to set up the experiment. I'm not going to show how to run it. Okay, so moving on, that's all on setting up the instrumentation things. Once everything is ready, the gasoline engine is the engine is ready to run the experiment. Okay, so I will come up over here. So firstly, we need to make sure we should allow the fuel to come into the input channel over here. Okay, so please make sure this is open, this is also open over here, and here you should select auto cycle like this. And there are also two more options, like do you need 8 ml or 24 ml. It's up to you. You can select usually 8 ml, or you can also select 24 ml. That doesn't matter much. But on this screen, you will have the input of how much fuel is consumed. That means you will get a fuel flow rate from the screen over here. Okay, so if you come over closer, as you can see, this is my fuel supply coming into the engine. This is my choke valve, so please make sure you use a proper position for the choke valve to run the engine. And this is my fuel supply on off switch, so please make sure it should be on when you wanna run the experiment. Okay, and choke should be at this position to start the engine. I have this lever over here. Okay, it's a kind of a manual mechanism. There is no power switch to run the engine, so please make sure you swing this string harder to run the engine. Also make sure this should be on, otherwise your engine will not start. Okay, so this should be on. Again, I will repeat, this power fuel supply line should be on. Make sure this is on. This choke valve is in this position. Once everything is done, okay, then use this string to pull it harder to run the engine. Okay, and that will help you to start the engine. After that, if you remember, in my previous video I talked like we're gonna run the experiment for 2 different RPMs. So this is the lever. If you come close, David, this is my lever which will help me to control the RPM. So as I mentioned in the slide, first we'll run the engine at high RPM, it's around 3000 RPM, and then we'll reduce the RPM with the help of this lever around 2500, and then we'll take the second set of experiment. So that's all from my side. Also please make sure this is my exhaust side, so during the experiment please make sure no one is standing in this direction, otherwise it might be harmful to anyone who is nearby. So that's all for today's in this video. We'll see you in the next. Thank you.